Hi, this is David Davis, and I'm proud to be joined here with Mr. John Blumenthal. He's the co-founder and CEO of Cloud Physics. Thanks for joining me, John.
Thank you for having us.
So I've looked at Cloud Physics. I learned about it at VMworld. I know you guys won some big awards at VMworld.
Yep.
And I'd like to learn more about Cloud Physics today. So why don't you tell us a little bit about the company history and what Cloud Physics is and how it can help VMware admins.
Okay. Yeah, for about 7 years, I served as the storage product manager for ESX, the core hypervisor in the vSphere platform. And during that tenure, I was constantly hit with really the same set of questions that customers would bring to me that were very fundamental. So things like, how many virtual machines and how many virtual disks can I actually put on a piece of storage? Very simple question to frame, very difficult question to answer. And so I set about trying to find this answer and started working with my co-founder, Irfan Ahmad, about ways in which we could predict what the effects of that particular configuration would be. And we found that there was nothing we were currently building or thinking about that actually could solve this very simple problem. And as customers started to go forward without having knowledge about what they should do in terms of putting virtual machines on data stores, we found that there was a significant amount of waste and risk that they started to incur without having a good answer to that fundamental question. And so Cloud Physics was actually born out of trying to answer that question. And as a consequence, we left VMware at the end of 2011 to raise money to actually build the company that you've seen at VMworld and many of the awards that we've just won in the last year.
Wow, well, very, very impressive story to come from VMware's storage and performance group and start your own company. So what makes you guys different than all the other virtualization management tools that are out there?
Well, so what we saw is because some of these fundamental questions couldn't be answered, we were also witnessing a lot of dynamic operations occurring in customer environments over the years. And at the same time, we were seeing a lot of the management approaches to these dynamic environments not keeping pace with the rate of change and the kind of change that produced different types of problems that these management applications were originally written for. So we decided to turn many of the aspects of the management approach that has been taken in the virtualization market on its head, beginning with a SaaS-based approach to delivering a new form of analytics and simulation that would allow a customer from the very inception and construction of a VMware environment, answering that fundamental question about how many virtual machines can fit on a data store, to the ongoing operation of a system that can be done with high degrees of efficiency and great deal of safety. Much like how Google and some of the larger infrastructures in the world actually operate was part of the core inspiration for the management approach that we've taken at Cloud Physics.
Okay, so you've got this big data approach, really, where you're able to gather statistics from thousands of virtual environments and predict how things will be or should be. So you got tired of telling customers it depends.
Exactly.
Right?
Exactly. And maybe I can come back to you with an answer, but what we saw as we started to analyze other large-scale infrastructures like Google as to how they would actually operate their back-end system, it became very apparent that they were taking a very new direction that inspired us to apply many of the approaches that large-scale infrastructure providers like Google actually engage in. And it starts with gathering massive amounts of data from heavily instrumented systems that they deploy into production and test. Once that data is then gathered together and deposited on a platform, fundamental models and analytics and simulations can actually be drawn from that data set. So the wonderment of the commercial computing world is that it's finally been normalized, and the success of VMware has proliferated the hypervisor in a way that there is a common touch point across every customer called ESX. That is a rich foundation of statistics and data and metrics from which we can gather, similar to how Google gathers from its normalized layer inside of its environment. And then that data is deposited, again like Google, onto a massive data platform that we run on as our back end, and a similar type of analytical and simulation-based approach to making design decisions and operating decisions for how to address a problem or predict potential problems is at the core of what we do. So it's taking many of the techniques and applications that drive some of the world's largest, most well-run infrastructures, and making those techniques and approaches available to the VMware admin.
Yeah, so I mean, there's so many virtualization tools out there that have pretty dials and widgets that show you CPU, memory, and disk utilization.
Yep.
But I think most of them, they kind of stop there. They don't go too much further. Maybe help you find a bottleneck here and there.
Yep.
But so what you're saying is, by gathering all this data from these really smart, very efficient environments, you're able to apply that knowledge and help really the world of virtualization admins.
Yeah, look at our consumer life, right? I drove down 280 to get to this interview today. Thank you very much. And I used Waze to find my way to get here. I live much further north, and I'm not down the south this frequently, so I didn't know how to get here. But I used data that was provided to me in a simple and direct fashion to get here. We think the VMware admin also needs to have that kind of analytical access at their fingertips in order to make safe and highly effective decisions about what they're going to do with their infrastructure.
Okay, so what are the most common use cases where Cloud Physics is helping?
So there are two that I'll highlight that we've seen a lot of demand for. And the first, I'll start with a procurement use case, which is a hot topic now in the industry in the form of analyzing whether or not the introduction of flash into an ESX cluster makes sense to you. What is the benefit I'm going to derive if I purchase this flash tier, this caching tier, and introduce it into my system? So at Cloud Physics, what we've constructed is a simulator that actually simulates these caches, these server-side caches, and allows us to take workload traces that we uniquely gather from an ESX cluster and replay those traces against the simulator. And as a result, we can very precisely tell the user what the benefit of that cache is going to do for a series of applications. So how much latency is going to be reduced by introducing the cache? What's the benefit to the cluster overall, as well as just particular workloads? And in the procurement process, this solves a really problematic pre-sales analysis problem where people typically spend up proofs of concepts that take a long time, they're very expensive, they're very inaccurate. And as a consequence, we actually have a couple partners that we're working with in the form of Fusion.io and Proximal as vendors who are actually starting to use this as part of their pre-sales process. We believe end users can use it to actually deliver a very effective and quantitative reason to take to your management about why you need to purchase this tier and who's going to benefit, what applications are going to benefit if I introduce it.
That's really unique. I mean, that's the first time I've ever heard of any tool that can help you predict, the effectiveness of, SSD or flash storage. So, I mean, we'll be talking to a lot of different storage companies this week, and that's a great question for them is how can they tell the end user that their tool is really going to provide the return on investment. So Cloud Physics can help there.
Yep, yeah. For sure. The second use case I'll highlight for you is at kind of the opposite end of the procurement and pre-sales process, which we're all hit with when you start to build out your infrastructure. The other use case that we are finding a lot of draw from users is really in the mission critical process of operating a high availability platform. So HA is a very common use case that users, and one of the strongest reasons users go into virtualization is to make the environment more highly available. Well, there's some unseen and lurking problems there in the way that high availability operates, in that as you start to configure your high availability policies, what is operating underneath it are a set of algorithms that do reservations of remote resources to ensure that a failover will actually succeed. Well, the problem with that is that there's so much dynamic change in the environment, different size virtual machines being placed in HA policy groups, hardware sometimes being reconfigured or re-provisioned. Those changes aren't accommodated by these HA applications. And as a consequence, you don't know whether or not your failover will actually succeed. At the same time, you don't know whether or not you're actually suffering from the accretion of waste on the remote system as you start to engage in HA implementations. And so what we built was a simulator that allows a user to change their HA policy, add new virtual machines that take different shapes and different sizes, and the simulator will tell you what will actually happen on a failover, whether or not it will actually succeed. So we're finding that a lot of folks are starting to use this in their change and configuration processes, and it's a mission critical application of some of the work that we've done on our back end.
And again, that's very unique. I mean, most admins drop their ESXi hosts into the HA cluster, sort of set it and forget it and just assume that it will work. So this is the first time I've ever heard of any HA simulator. So, and I know you've got some great high-profile advisors on that, Duncan Epping and Frank Denneman, who wrote the book really on HA and DRS.
Yep. They've been great advisors. We worked with them for years, even during our time at VMware. In fact, one of our cards, which is our metaphor for these focused applications that I've been talking about, actually applies many of the principles that Duncan and Frank have written about in their books. So it's literally, in one case, an HA health check that applies many of the best practices that Frank and Duncan have written about.
Wow. So those are just really two of the cards in your card inventory. So how many cards roughly are there?
So a community, we have a free edition that we introduced in September at VMworld, and that has brought on board some community interest that has spawned upwards of 250 or so cards that are separate from the Cloud Physics developed cards.
Okay.
Both of these sets of cards, though, are developed and deployed off of our platform, which has different types of accesses that Cloud Physics uses to develop its own specialized set of cards. We have the platform has access, or can be accessed by community members and end users through what we call the card builder. And this is a drag and drop interface that allows you to do very powerful things off of our platform without any form of scripting and database engineering. So it's also seeing a lot of interest from the community especially.
So a GUI to build your own performance analytics reports?
Yes. Cool. Configuration reports. It really has a very rich and very complex capability that's delivered in a very simplified form.
Okay. So if someone wanted to get started with Cloud Physics, what's the process?
Just go to our site. It takes a couple minutes to just register an account there. You download our virtual appliance, which we call an observer. And this virtual appliance you load into a virtual center and provide it read-only credentials to start pulling data from the vSphere APIs. And that data is anonymized and shipped to our SaaS-based service. And within 5 to 10 minutes, you can actually start engaging cards which are populated with your data set, and only you can see those in ways that apply analytics in some of these simulators that I've been mentioning to your specific environment.
Okay, so there's a free community edition, and then there's a per host monthly software as a service edition.
Yep. So it's divided into tiers. There's a standard and enterprise edition. The pricing and the packaging and those things can be found on our website.
Okay, but there's, unlike some other virtualization management tools, you don't have to make a large initial CapEx purchase to get started with it.
Exactly right. It is based on a monthly subscription fee.
Okay.
So it's very easy to get started with us. Literally takes 5 to 10 minutes.
Very cool, very cool. That's one of the many things I like about Cloud Physics. It's really a unique product, software as a service, monthly subscription, easy to get started, and you bring the community in to build their own custom performance analytics.
Yep.
So we've got some more great videos, I understand, with your engineers where they're going to go into detail on each of the different cards and use cases. So I really appreciate your time. Thanks for joining me today, John.
Likewise. I greatly appreciate it.